In this video, we will look at how to carry out factorization. Factorization is the process of expressing an algebraic expression as a product of its factors. It is the reverse of expansion. For example, the linear expression, 2x minus 8, can be factorized into the product of 2 and x minus 4. By expanding 2 and x minus 4, we get back the linear expression, 2x minus 8. We can also factorize quadratic expressions. We will look at 5 ways to carry out factorization. First, by extracting common factor. Second, by grouping. Third, using a multiplication frame. Fourth, using the cross-multiplication method. Lastly, using algebraic identities. The first approach is extracting the common factor. As the name suggests, we will extract factors that are common to all the terms. Using the expression, 3x squared minus 9y plus 15 as an example. Start by identifying the factors for each of the terms. Next, identify the factors that are common to all. That factor is 3. The factorized form is the product of that common factor, 3, and the remaining terms divided by 3. Looking at another example, 2a squared plus 12a plus 6ab. The common factors of each term are 2 and a. By extracting the common factors, the factorized form is 2a multiplied by a plus 6 plus 3b. The next approach is by grouping. Grouping is used when there is no common factor among all the terms. We separate the terms into 2 groups, based on them having common factor. Looking at the expression, 2x plus xy plus 3y plus 6. There is no common factor among all the terms. We group 2x and xy into a group as they have a common factor, x. Factorize out x. 3y and 6 has a common factor of 3. Factorize out 3. After factorizing each group, there is a common factor, y, plus 2. Factorize out y, plus 2. After factorizing, the factorized form is the product of y, plus 2, and x, plus 3. The expression, 6m, minus 12mx, minus 4x, plus 2. The expression can be factorized by grouping 6m, minus 12m, together, and minus 4x, plus 2 together. Factorize out the common factor in each group. The common factor between the groups is 1 minus 2x. After factorizing out 1 minus 2x, the factorized form is the product of 1 minus 2x and 6m plus 2. The expression 6m plus 2 can be factorized further by extracting the common factor 2. The next method is by using a multiplication frame. This method is mainly used for factorizing quadratic expression into a product of 2 linear expressions. Using x squared minus x minus 2 as an example, start by drawing the multiplication frame. Write the x squared term in the middle and the constant, negative 2, in the lower right corner. We have to find two terms when multiplied will result in x squared. In this example, the two terms are both x. Write x in the two boxes. Next, find two terms when multiplied results in -2. They are -1 and 2. There are other possible combinations, and we can use any of them as we will check if the combination is correct at the end. Fill up the two numbers in the box at the top right and at the bottom left. The numbers can go to either box. We will check if the position is correct at the end. Fill up the two remaining boxes by multiplying. The two terms are -x and 2x. To check if the position and the terms chosen are correct, add 2x and -x. The result is x. In the quadratic expression, this term should be -x. Since we did not get the correct result, we have to go through a few iterations. In this instance, the number used should be 1 and -2. By doing the same check, the result of adding x and -2x is -x. This is the correct combination of terms. The last step is to write the factorized form. The two linear expressions are x plus 1 and x minus 2. The next method, using the cross-multiplication method, is similar to using a multiplication frame. This method is mainly used on quadratic expressions. To factorize the expression 2x squared minus 7 minus 15, start by drawing a cross. Write 2x squared and the constant -15 into the position shown. We fill up the first column with two terms that when multiplied results in 2x squared. The terms are 2x and x. For the second column, we need two terms that when multiplied results in -15. Similar to the multiplication frame method, the position and combination does not matter at this moment. We will check them later. To fill the last column, we will cross-multiply. Multiply 2x and 5. Multiply x and -3. The results are 10x and -3x. To check if the combination and position are correct, add 10x and -3x. The result is 7x, which is wrong. The correct term should be -7x. After some iterations, the correct terms are 3 and -5. The last step is to write the factorized form. The two linear expression is 2x plus 3 and x minus 5. The last method we will be discussing is using algebraic identities. These are the three identities being used. Any expression that is in the form on the left side of the identities can be factorized into a form on the right side. Let's look at how to use the first identity. The quadratic expression, x squared plus 8x plus 9, seems to be in the form of the first identity. However, we have to check if that is true. Identify the term a and the term b. In this instance, a is x and b is 3. Work out the results of 2 multiplied by a and by b. The result is 6x, which is not correct. The correct term is 8x. We cannot use the identity to factorize this quadratic expression. Looking at the next quadratic expression, 4x squared plus 12x plus 9. The term a is 2x and the term b is 3. The results of 2 multiplied by a and by b is 12x, which is the correct term. We can use the identity to factorize this quadratic expression. The factorized form is the square of 2x plus 3. Moving on to using the second identity, we have to do the same check as we did for the first identity. For the quadratic expression, x squared minus 8x plus 16, the term a is x, and the term b is 4. The results of 2 multiplied by a and by b is 8x, which is the correct term. Please note that the 2ab term is 8x and not negative 8x. The negative sign has been accounted for in the identity. The factorized form is the square of x minus 4. The last identity is used when the expression is the difference between two perfect square. It cannot be used when either one of the terms is not a perfect square. Both terms in the linear expression, 36x squared minus 9y squared, are perfect square. The term a is 6x, and the term b is 3y. The factorized form is the product of 6x plus 3y and 6x minus 3y. Sometimes, a combination of methods may be needed to factorize the expression completely. In this example, we need to use the first identity, followed by the third identity to factorize the expression completely. The next example can be factorized by extracting the common factor, 2, followed by using the cross-multiplication method. Remember to always check that an expression is factorized completely.